Well, hello, Nick here, M0NTV, and welcome back to my shack. Now, long time no see. Sorry, I've been doing other things, and notably building this. This is my 17-meter radio, but we're taking a break from that today, or at least a pause. Just because this is partly why I haven't been making any videos really, because I keep getting distracted with building other things. But I was down at my local radio club the other week, and a guy, I walked in the door, and a guy says, "Oh, I'm glad I want to show you this thing," and he showed me this little plastic case with some RF connectors on the side and a toroid in the middle, and windings of wire on it, and it was all melted and all the wires were melted. I thought, what the heck is this? He says, well, this was the transformer I had connected to my long wire, you see. And he says, it's supposed to be good for 400 watts. And he says, I never put more than 100 watts through it. And I looked at this thing, and I could manage to kind of count. I ascertained it was a 9-to-1 UnUn. And I'll say a bit more about what that is in a minute. And I've built a couple of them myself in the past. They're really useful if you've got like an inverted L, a kind of random wire, as it were. You can use as a multiband antenna with a tuner. But it was wound really badly. And this was a commercial product, and it's not the first time, actually, that I've heard of these things melting. But the way it was wound, the wire was all bunched up together and wasn't spread around the toroid. I wasn't even sure what the toroid was, just not really very good. And they're not cheap either. I mean, people can sell these things for £40 plus, UK pounds. So he said, "Can you do anything?" I said, "I can build you one that works." I think so. That's what I did. So I came home and I built him this, and this is my 9-to-1 UnUn, and we'll have a quick look at it there, but I'll tell you a bit more about it in detail. So and this video is just going to be quite a short one really, but just telling you a little bit about what this is and how to build it, and how you can build them fairly cheaply, really. Fortunately, I had all the parts to do this. Even the FT140-43. So the 140 is the size, and the 43 is the ferrite type. And it's made with if I hold it up, you'll probably see there. That's better, isn't it? It's made with the thundering great big 20 gauge enamelled copper wire. There are banana plugs there for the antenna and for the ground or the counterpoise, and there is a PL259 on the end, which will go to the transceiver. So let me show you the schematic, and hopefully it'll make a bit of sense. So here is the website that I based my design upon. So this is vk6ysf.com, and actually he has a number of designs for an UnUn. This was his version 2, and I did, as I say, I didn't build it exactly like this, but this was this is good enough to kind of show you essentially what it's about. Yeah, and what is an UnUn? Well, an UnUn takes an unbalanced signal, like you would get from a long wire and a ground, and transforms that to another unbalanced signal, such as you would get from the centre pin of your coax and the shield and ground of your coax. So it takes an unbalanced signal and keeps it unbalanced, essentially, unlike a balun, which takes a balanced signal, like a centre of a dipole or like a twin feeder, and takes that to an unbalanced thing. So you might think, well, why would you want to transform an unbalanced signal if it's unbalanced anyway? Good question. The main reason is to transform the impedance. If you've got a long wire like you can see here, or a random wire really, because a long wire is one that's kind of longer than you need, isn't it, technically, but a random wire with ground or a counterpoise, you will find, because it's generally end-fed, it will have an impedance much higher than your transceiver will want to see, i.e. 50 ohms. And this is where a 9-to-1 UnUn can come in handy, because what it actually does is it transforms that high impedance into something closer to 50 ohms. So 9-to-1, essentially we're talking about 9 times 50, so it's 450 ohms. So it will take a signal from that antenna with an impedance around about 450 ohms and bring it down to close to 50 ohms, or at least close enough so that your tuner will, or your antenna matcher, will be able to match it. So, you know, it won't be miles out, and you'll be able to do it. So now sometimes you can get lucky and it'll bring it down almost so you don't even need a tuner, but most of the time you will, particularly if you're going to use it in a multi-band setting. So that's what it is. Now, it's called a 9-to-1 because the 9, this is quite confusing because he calls it a 9-to-1 voltage UnUn, and that's very confusing because actually the 9 in this is actually the impedance transformation. Technically, it's a 3-to-1 voltage UnUn and a 9-to-1 impedance transformer. Now, if you have a look down here at the diagram, you'll see essentially what it is here. So we're assuming here that we've got the long wire on this end. This is the high impedance end, and then you've got the transceiver on this end, on the 50 ohms end. Now, these refer to the 3 windings, and these dots are the phasing dots. So what this means is this first winding, you've got the top of the first winding, which goes down to the bottom of the first winding, then the top of the second winding down to the bottom of the second winding, the top of the third winding down to the bottom of the third winding. So these dots signify the top, and that's because you wind these trifilar wires together. Now, you don't twist them up like you would do perhaps with a smaller diameter wire if you're doing some impedance matching in a transceiver. You lay these wires next to each other, kind of like this, as you can see in this diagram here. And so they're kind of next to each other in groups of 3. Now, there are other ways of building an UnUn, but this is just this particular one, and this is the one I chose to do. You wire some of these together so that what's happening is the bottom of the first wire goes to the top of the second wire, etc., as it's shown here, and then you tap off, as it were, the 50 ohms bit on the end. So it's really just how you connect the ends of those wires together. Now, if you use different coloured wires, as you can see here, that makes life a lot easier because you can instantly see which one's which. Now, because my friend's UnUn, the plastic coating just melted on his, and I didn't really want to leave anything to chance. So, and I'll show you my UnUn again in a minute, but I elected to use enamel coated wire, but beefy stuff, so 20 gauge, so it's thick stuff, coated in enamel, and that stuff is not going to melt unless it gets very very hot indeed, and probably the box will melt before the enamel melts off the wire. So that shouldn't be a problem. Now there's 10 here. Now I put 10 on mine. Now actually, when he builds the thing down here, I think he only uses 1, 2, 3, 4, probably 5 there. you can use more than that. You just don't really want to use less than that, because I won't go into all the details why, but it's about the inductive reactance. If you can fit more on, generally speaking, that's not a bad thing, as long as you can do it with a bit of space in between them. And the important thing is when it's quite fiddly to do. It's keeping these wires flat and straight so that they're all in the same relative position. Now I chose to use the same wire, which was difficult because then they all look the same. So you have to just keep using the multimeter and just determine which one's which and label them once you know which one's which, so you don't stuff up the wiring. But it's not difficult to wire up, and there aren't any more parts to it than that, other than you have a connector. I used a banana plug for the antenna. I used another banana plug for the ground, and then I used a PL259, or sorry, an SO239 for the connection to the transceiver. And now I don't have any doubts that the one that I've built will work okay, and I'll show you some tests I did in just a minute. But I haven't actually tested it for real. He's going to do that himself. I think the only test will be how much power it can actually take. I mean, I think it should be good for 100 watts sideband, but we will see. If it comes back melted, I think I need a bigger toroid, or maybe two toroids. You can put two toroids together if you need a bit more power handling capability. So here we have the 9-to-1 UnUn again. I've just kind of propped it up here, so hopefully you can see. So yeah, I wound those 20 gauge wire, trifilar wire around, and you'll see two of the wires just get shorted together, just connected together, don't go anywhere, they just connect together. Two of the wires get shorted together and go to the center pin of your SO239, and then one of the wires goes to ground and one of the wires goes to the antenna. And you'll see I put the ground there and just put an extra wire coming down to here because it was easier than trying to stretch that wire around to there. And then I glued the toroid into the box. As a matter of fact, I used some of that UV welding stuff. So that keeps it in there nice and secure. And these little boxes are great, actually. So I just bought a whole load of these, I think from Amazon. And they're actually perfect size. Now, they're not perfect size, really. For most of my SO239s are a different design to this, but I happen to have a few of these, which are slightly smaller. It only just made it, as you can see, it kind of overhangs. But once the lid is on, then that's fine. That seems to work okay. And yes, those are the banana plugs there. Yeah. So now what I advise my friend to do once he's tested it and he's happy with it is to just weatherproof your connections here, and probably at where the coax joins as well, just to be on the safe side if it's going to be left outside, because water always seems to find a way. Yeah, so I tend to use some of that liquid electrical tape, which is foul smelling stuff. It's really horrible, but it's superb. It forms like a kind of consistent kind of rubberized layer then over whatever you paint it over. So that's quite useful for any kind of antenna work and weatherproofing. So yeah, so there it is. So as I said before, really, I'll show you some tests I did now, but the only thing I haven't tested is actually using it with a real live antenna. So my friend will have to do that, and let me know how he gets on. The question, as I said, really is
just simply how much power it can take. It is quite a fat toroid, as you can see there, so it will have a pretty reasonable power handling capability. But yes, so then the only way to safely do that, I think, would be to kind of set your radio up, maybe put it in CW mode or even FM mode, and kind of key down for so many seconds, and then go and touch the toroid. Not obviously while you're transmitting. That's not a good idea. But when you're not transmitting and it's safe to do it, just touch it, and just see how warm it is. Getting warm is fine. You don't want it getting blisteringly hot though, because that's going to start to mess around with the SWR as well, and actually kind of. In a way, it kind of desensitizes the toroid itself. They do recover, apparently, but actually, you kind of almost change the properties that the toroid has if you put too much power through it. But as I said, what you can do, of course, is use a bigger toroid. I mean, this is 140. You use a 240 if you wish, or the website I showed you, he has another design where he uses the same side toroid, but he spaces all of these out. Well, he actually uses a different design. He kind of taps it off. He doesn't use a trifilar. He uses a different method and just spaces everything out and puts some more distance between all these turns. So there are different ways of doing it. But yes, I've made a couple of these now and used them for some time, and they've always worked pretty well. They're kind of things you build and then you weatherproof and you forget about. And actually, I brought mine in, the first one I built, and it looked pristine in the box. It still looked as it did when I built it. So it managed to survive the ravages of the UK weather pretty well. So let me show you how it fared when I tested it. So what I did to test the 9-to-1 UnUn was to put two resistors in parallel together, actually, to get round about 450 ohms, and put those across the red and the black connectors for the antenna and the ground, simulating the load of the antenna. And then I connected my Nano VNA into the SO239 socket. So if the transformer is transforming properly, what it should be doing is showing me a good 50 ohms match, because it'll be transforming that 450 ohms to about 50 ohms. And so if you look, this is just a screenshot from the VNA Saver program, which is very good, which enables you to kind of view the results of your Nano VNA on the larger screen of your computer. So on the left, you will see the SWR graph, and this is a sweep from 1 megahertz all the way to 51, and the reason I did that was my friend's original UnUn was supposedly going from all through HF up to 6 meters, so I thought I'd do the same. And you'll see it's really very good. If you look at the scale on the left hand side, the highest that gets to, that little pale blue marker, the little inverted triangle on the left hand side there, it is in between 1.67 and 1.89, so well within the range of your tuner. But if you look at the HF range, where the dark blue triangle, that's actually 1.25, so that's really very good. Now, of course, your antenna is very unlikely to present you with exactly 450 ohms. But what I did do, actually I didn't record this, but I tried, as the guy who designed it as well did, tried putting some different resistors to simulate different loads. So a higher load, I put a 1 k ohm
resistor across it. A lower load, I put a 100 ohm resistor across it, and see what it looks like over this same frequency sweep. And it's pretty good. It's it's all well within the range of a normal tuner. And in fact, I mean, I've got a rig that has an internal tuner. It's well within range of even the internal tuner. So I mean, should work okay. Should work okay. And just for interest, this what you're seeing here is, again, it's the same frequency sweep along the bottom on the x-axis, and on the vertical y-axis, what you've got is the impedance. And although it looks like there's a lot of variation, if you look at the scale is not that big really. It's only going 30 to 60 ohms. So so it drops down well within the HF range to somewhere between 38 and 40 ohms, and it's close to 50 ohms lower on down the band. So which is reflected by the SWR. So all in all, pretty pleased with that. Well, hopefully you enjoyed this brief little detour into the wonderful world of antenna coupling, and perhaps have a go at home brewing your own 9-to-1 UnUn. Next time, hopefully, we will be back looking again at the transceiver, and bringing you up to speed with some of the things I've been building and looking at doing for that. But until the next video, thank you very much for watching. Look after yourself. 73. Bye bye.